Right, graphing functions. So where does graphing functions come up? On paper 2, generally question 7, sometimes 8 and 9, but generally question 7, they give you a longer trig question. And what's thrown into the longer trig question is a 3D problem, area and volume problem, it's kind of stuck somewhere in the middle of it. And then they generally get you to draw a graph. Alright? So when that happens, we have to know what certain things mean. So we got to start with the basics and work our way up. So we're going to come to this now in a minute. This is basically, so it's A plus B times the cos of Cx as well. They're the two main ones. Tan doesn't really come up, but look at tan, but it doesn't really come up. Main side of this. So, before we get to those, we'll look at drawing the sine of x first of all. So, the very basic one, we'll look at graphing the sine of x. So, what we're going to do is graph the sine of x So we're going to graph the sine of x in the domain between 0 and 360. Zero, 90, 180, 270, 360. Now, the easiest way to do this is put it into function mode. So anyone who has this calculator, I can help you. Anyone who has a chart, have it. Great. We fired ourselves about 10 years. So, anyone has this one, the easiest way to do it is hit mode and 3 for table. Remember have fx in front of them? Literally write in the sine alpha x. Then we have to put in sine of x. Hit equals. Right, where are we starting? Hit 0. Hit equals. Where are we ending? 360. Hit equals. And the step is what you're going up in, what you're going up in. 90s. And there straight away it gives you out all your points. For those of you who have that calculator, you have to work them out individually. It's work them out step by step, by point by point by point. For anyone who has a Casio, it just fires them out you straight away. Because they don't know, like the weak math probability and statistics and all that things is to do, I don't always use that. I'm afraid. So, there's all your points 0, 0, 91, 180, 0, 270 minus 1, 360, 0. We all have those points? Right, draw in the graph that. So as I said, for the rest of the you have to get the sine of 0, the sine of 90, the sine of 180, the sine of 270, the sine of 360, and put down your points like that. Right, our points are, for 0 we get 0, for 90 we get 1, for 180 we get 0, For 270 we get minus 1, and for 360 we get 0. Are we happy with that? So we're going to draw a little graph of that then, because it's going to be important to how this formula over here affects our graph. So, for example, I want you to draw a little graph that looks a bit like that. I said put down here in degrees instead of radians. I've got to change that to radian degrees. So off you go and draw a little graph for me. We all got that little graph done? So obviously, pi stands for 180 and 2 pi stands for 360. Down here is 270 and pi over 2 is 9. Is that alright? Right. So, that is the sine of x. Next thing we want to do is we want to look at the sine of 2x. I'm going to show you what effect this left side here is. I'm going to show you what c affects. Is that okay? So we go back to our graph, and we're going to get the sine of 2x. So those of you with the Casio calculators, just go back and change your function to the sine of 2x and use all the points again. Those of you with the sharp calculators, go back and recalculate all your points again. So one more minute, have a go at that. Right. You see our graph? For this to work, we got to change it a small bit because we're going to end up with 0, 0, 0, 0, 0, 0, 0, 0, 0. That's my fault, right? In between each one of these, 45. I forgot that would happen. So 45 onto 90, 1, 3. 135, 45 onto 180, 225, and 45 onto 270 is 315. So when you do that, then the values you get for your bottom one is put them into calculator. So the only thing you have to do is change your step from 90 back to 45. So you get 0 here, you get 1, 0, minus 1, 0, 1, 0, minus 1, and 0. Is that okay? Right. What effect does that have on our graph? The following. So the effect that has on our graph is, this was our original one, where 90 came up, you get you 1, goes back through 180, down to minus 1 for 270, and back to 0 for 360, yeah? What effect has our sine of 2x graph had? Period, exactly. What was our period? Our period for sine of x was? What was that? For the original sine of x period was? 360 degrees. So we're believing in degrees for the time being. I can't change the accent at the moment for some reason. So our period was 360 degrees. What is our period now for the sine of 2x? 180 degrees. It's doing a full revolution. It's going up, down, goes back through at 180. Whereas the sine of x was going up, down through 180, and didn't fully revolutionize until 360. The number inside here affects the period graph. Does that make sense? Alright? So the number inside here, C, affects our period. And that's what that does. So obviously, sine of 3x will become tighter again. Sine of 4x, tighter again. Sine of 5x, tighter again. 6x, and so on and so on and so on. Is that alright? How do you figure out what it is? The period for a sine graph is 360 degrees. The period for a cos graph, 360 degrees. 2 into 360 leaves you 180. What would be the period for a sine of 3x graph? 3 into 360 is 120. 4 into 360, 5 into 360, and so on. So you know then what your period changes. Does that make sense? Right. We're going to check what happens when you put 2 in front of sine x this time. Is that alright? So we're going to get the graph of 2 sine x this time. So we go back to our function and we get this time 2 sine x. Once again, you put the figures into your calculator and work them out whichever way you can. Starting at 0, ending at 360, and the step is 45. Round to 1 decimal place. 0. And we should be getting those values. 0, 1.42, 1.40, minus 1.4, minus 2, minus 1.4, and 0. Sorry. And if we look at the graph then and what it looks like, we go to here, we say, so we compare it to original sine of x. And what can we see? What has changed? There. So all we're looking for right now is from 0 to 360, 2 pi. The maximum end. What's that one? I don't know what that is called on the graph. So for the sine of x, the range was originally from what? On the sine of x. No, period was 360. The range was 1 and minus 1. Maximum height was 1, minimum height was minus 1. So it was 1 to minus 1. That was the range. Now, 2 times the sine of x. What's that to be in effect? What did you say it was effect? Our maximum minimum height, which is known as our range. So what's our range going to be from? 2 down to minus 2. So there's our range. 2 to minus 2. If it was 3 sine x, the range would be 3 minus 3 equals, and so on and so on. Is that okay? Right. The last little thing we're going to look at. We're going to look at 3 plus the sine of x. What happens if you put a number out here and then plus the sine of x? So we're going to get this, 3 plus the sine of x. So we're going to say 3 plus sine of x. Oh, it's anyone using the Casio? Look up, Adam, Abby. Don't hit the on button. Hit the AC button because it doesn't delete everything. If you hit the on button, all you have to do is go back and change a few things. You don't have to re-input everything. Use the AC button, not the on button. So, when we use 3 plus the sine of x, we get 3, 3.7, 4, 3.7, 3, 2.2, 270 is 2, 2.2, and 3. To those of you using Sharp, it might be no harm. You need a second calculator going into your leaving cert anyway. Don't ever go into leaving cert with only one calculator. You're looking for something to go wrong. 2 calculators going into leaving cert, and that's minimum, alright? If you are looking to get a second one, I recommend getting one of these. I know if you're next door, Berna, and where the second teacher is using the Sharp, these are much better. And they're handier to use, more user friendly. If you are getting a second one, you need a second one for your leaving cert. If you are getting a second one, get one of these. Just because everything I'm going to teach you now, especially when we move on to probability and statistics, where you get like standard deviation and correlation, this just does it all for you. Mean, mode, all that. Get one of these for a second calculator. Is that alright? Right. So we look at our graph then, and we get the following. So we compare it to our first one. What has happened? It's just shifted up. It's the exact same thing. It's still got a range of up of 1 and minus 1. It's still going up 1 and minus 1. But the only thing it's done is it's moved from here up to, where does it start now? Because our function is sine of x starts at 0. 3 plus sine of x starts at 3. It's cutting through. 3. It's the exact same graph. The period still is 360 degrees. It doesn't go back through 3 until 360 degrees. The period hasn't changed. The range now is like 4 and 2, but it's still jump plus or minus 1. The range is 4 minus 2, right? But it's still plus 1 minus 1. Range hasn't changed. The only thing that has changed is you're moving your starting point from 0 up to 3. And that's what happens with A. Alright, so you want to put the letters next to this letter is B, and that's the effect that has. And this letter is A. And this letter up here on top of it is C. This formula comes up, and this one also, depending on which graph it is. To be exact, so 1987. Not sure you're wrong. Right. What I want you to do is, I want you to do one for cos for me. So I want you to get me cos of x, cos of 2x, 2 cos x, and 3 plus cos x. I want you to compare your graphs. You have to understand what both of them look like. So I want you to do the exact same for cos. I'll write up the ones I want you to get for me. And anyone struggling, I'll be floating around while you're doing this then. You should. I just left it out. It's alright, you can go with Paddy as well. Obviously, Adam, keep a straight face and call me, sir. So anyone who's having a bit of trouble, just give me a shout. the 3D problems then for the last hour. 25 minutes after now. start and figure first. That's what your cos of x should look like. And notice the difference between the cos of x1 and the sine of x1. The first major difference. Sine goes through 1 at the start. That's 0 on the y-axis. Alright? Sine goes through 1. So it revolutes every time it goes back up through 1. Cos goes through 0, sine goes through 1. Important to know that because they've often popped the graph in front of you and you try to figure out what it is. So I said you can change your axis to degrees if you want, or you can leave them radians, whichever you find easy. Cos of x, the cos of 2x, 2 cos x, and 3 plus cos x. So 1, 2, 3, just 4 in one graph. Go away from here. If you can multicolor pen, I recommend drawing one green, blue, red, just so you know which is which. Maybe 4 more minutes to finish that up before we move back. Right, we'll have a little look at them and then I'll let you finish them off in your own time. It's important you do them, guys, because they do come up. So I want to jump on to 3D problems. So, the cos of 2x then, once again, what does the number in front of, what does C affect? The number in front of x affects the period, exactly. So, it doesn't revolutionize through 360 anymore, it goes through 1/8. You can see it goes up, down, back up, 1 every 1/8. And then we look at 2 cos x. And remember what 2 cos x is going to affect? The range. 2 cos x is going to affect the range, i.e., it's the exact same. Here it goes through 360, which the range goes from 2 down to minus 2. And the last one, Adam, any idea what 3 cos of x, 3 plus cos of x is going to affect? It shifts, exactly. It shifts where it starts. It shifts where it starts. So it doesn't start at 1 anymore. It shifts up 3 spots. It now starts at 4. The period is still the same. It still revolutionizes every 360 degrees. And the range is still the same. It goes plus 1 and minus 1. The only difference is your range is now 4 and 2 because of the 3. It's after shifting up 3 spots. Right. Let's have a look at a few 3D problems. And we're going to start these by jumping straight into exam papers and looking at them. There's a bit of what we've done already in this. Right. So, 2018, paper 2, question 9. 3D problem comes up, paper 2, every year. So you're going to get a 3D problem of some sort in paper 2 every year. In engineering, a crank and slide mechanism can be used to change circular motion into motion back and forth in a straight line, i.e. this crank moves around like this and this slide goes in and out as that moves around. It's also the exact same question, I use our 2012 perfect too, so they love these arms that go revolutionary and go around and around. In the diagram below, the crank OD rotates around a fixed point. The point C slides back and forth in a horizontal line as the rod connects C to the crank. The diagrams show 3 of the cost positions for C and D, where OD is 10 centimeters and DC is 30 centimeters. Right. So, an awful lot of information in there, and all they're really trying to tell you is this rotates around, this slides in and out. That's what that's how they explain it. Down here, they then just say what the 10 centimeters and 30 centimeters means is the connecting rod is always going to be 30 centimeters because it's a piece of steel. Shrink or expand, and the crank is always going to be 10 centimeters, i.e. piece of steel, it's not going to shrink. Is that okay? So what they want us to find in is the angle C, O, and D. So with that in mind, how are we going to go about getting C, O, and D? Right, it's a triangle. Yeah? First things first, triangle. Is it a right angle triangle? So, first thing you always ask us, is it a right angle? If no, Pythagoras is. Can be Pythagoras, can be sin cos tan. That's all. Okay. Pythagoras gone, sin cos tan gone. So stop thinking about them for 10 minutes. So it's not right angle triangle. We trace 2. What are cosine rule and the sine rule? So cosine rule and the sine rule, logbook, page. Oh, I didn't take a picture, right? I did 16. Page 16 in the logbook. Now, we always attempt to use which one first? Sine, banana. What do we have to check for sine? What do we have to check for sine to work? This is angle A, so this is side A. This is side B, so this is angle B. You can see capital letters represent angles, small letters represent sides. Now, we check the sine rule first. what has to happen for the sine rule to work? We have to be only missing one of what? One of 4. What I mean by one of 4 is you have to have side up, an angle opposite the side, an angle opposite, and then just be missing this. Does that make sense? You need to have a side and an angle opposite each other that you must have, and then you must have the angle or the side opposite one here. And then kind of a roundabout way I'm not explaining that. So if we look down here, we have an angle. So first of all, what are we looking for? We're looking for C, O, and D, isn't it? So, do we have the side opposite? We do. Do we have an angle on another side? We do. So we can use the sine rule. Off you go. Okay, the C, O, D. Everyone's alright, guys? You show us again as well. Yeah. 55 937. Should be happy with that. 31 seconds, and we'll go back off it. Right, let's have a little look at it. So, I'm going to call this angle A, side B, angle B. So, A, 10 over the sine of 15 is equal to B, which is 30 over the sine of B. Now, the easiest way to go about this without messing up, maybe rounding off figures, is to leave them as they are until the very end, until you need to do something with it. So what I mean by that is, I want to get sine B off the bottom line. So I multiply across by sine B and sine B, and I multiply across by also sine of 15 and the sine of 15. So sine 15 knocks with sine 15, sine B knocks with sine B. So that's the sine of B times 10 is equal to 30 times the sine of 15 degrees. And then I divide across by 10 and 10. So the sine of b is equal to 30 times the sine of 15 over 10, and now I put that into your calculator instead of rounding off a lot of figures at the beginning. You should end up with the same answer, and usually it's corrected nearest degree, so you should be alright. But just it saves the amount of work you have to do. The sine of b is equal to 0.7764. b equals sine inverse of 0.776457. And you get b is equal to 50.937, which is how many degrees? 51 degrees, the nearest one. We happy with that? Good stuff. Right, next part of the question. Told you. So, as d moves in a circle around O, the angle alpha in the diagram below increases the distance cx and can be considered a function of a written as the f of alpha. Write down the period and range of f and complete the table below for the function of alpha. So, how are we going to go about this? Do we know what is going to happen here? So what I recommend, even though they have I done first, I do I before I do I here. Because they don't actually give me a function, so I can't tell whether it's sine and cos and what's the period, what's the range. But if I get all these values, I'm able to go and fill in what's my range, what's my highest, what's my lowest, and so on. So, at 0 degrees, the f of a is 30. So do we know first of all what they mean by when they say, why do they have when they say, I shouldn't say a, I should say alpha. Why do they talk about alpha? I don't know by reading that question. It's worded very difficult. Yeah, see, the way they word it is they make that horrendous to read. So as d moves in and around the circle, in the diagram below, increases the distance cx considered a function of alpha written as f of alpha. i.e., the distance from here to here is the function as this moves around the circle. So when it's 0 degrees, when alpha is 0 degrees, this is going to be flat down here, isn't it? So the distance from c to x is 30. When alpha is 90 degrees, i.e. when alpha is up here, what is the distance between here to here going to be? That's what they're looking for. Does that make sense? When d is 180, so when alpha is 180, that's going to be all the way over here. They want you to figure out what the distance from c to x is, i.e. the function of alpha. And when alpha is 270, i.e. back over here, what is the distance from here to there going to be? And when alpha has gone the whole way around 360, what is c to x going to be? So they're saying that this is a function, 90, 180, 270, and 360. Right. There's one we know straight away. Which one do we know straight away? There? 360, the girl. What's 360 going to be? 30, because it's gone the whole way around and it's back in the same spot. Again, so we know 360 is going to be 30 degrees. Now, there's another one we should know straight away as well. Which one do you reckon we should know straight away without doing any formulas? Not 19 over. 180. Why 180? This, when I move the thingy, exactly. When I move the thingy over here, it's going to be 180. So, what? Remember from the question above, what do I know? What measurements do I know don't change? What did I say? Two things don't change. The steel things, exactly. This one is going to be, you see it here already. 30, and what's this going to be? 10. So this is all the way over here. What's the distance from C to X going to be? This is 30, yeah? It's all the way over here. What's the distance from here to here going to be? 20. Exactly. So what's the distance from here to here going to be? 10. The bar is 30. So this whole bar, this is my C, this is my D. The angle is at 180 degrees. If the bar is 30 degrees, 30 centimeters, that can't change. And what's the radius from the middle of the circle? 10 and 10. Take 20 away from 30, what's going to be left from here to here? Right, so we know 180 is going to leave C to X as 10. Right, the only one we haven't got so far then is 19.27. What do we know about 19.27 is going to be there? Yeah, here and here. This is going to affect here. Right, anyone any idea what we're going to do that? Deal with a triangle. What's the first question I said? Ask yourself. Is it right angle? So that's all up there. At 90 degrees, is it going to be a right angle triangle? It's going to be a right angle triangle. So we're going to use Pythagoras theorem. Right off the go, use Pythagoras theorem and see can you figure out what the distance from C to X is going to be. You got 18.2 for the distance from what? From C to X or C to 0? C to X. 18.2. Because we got C to 0 knows. 8.2. And what we know, the crank doesn't change size, crank is always going to be 10. Stuff. Right. See then, can you fill in the period and the range from what we did this morning? And I correct the whole thing then. Right, let's have a little look at it. So, we said 180 is going to be 10, and we said 360 is going to be 30. We drew a right angle triangle. And we knew the distance from here to here is 10. The lever doesn't change, it's 30, and we're looking for this, which was C to O. So 30 to be squared minus 10 to be squared equals x to be squared. So it's the square root of 30 to be squared minus 10 to be squared equals x. Square root of 30 to be squared minus 10 . 28.3, 28.284. I just threw all Pythagoras into one there, that's what I did, just skip a few steps. Minus 10 is 18.284. Give your answer correct to 2 decimal places, 18.28. Are we happy with that? I took away 10 because that's the crank. Right, off you go, use your tables, draw a rough sketch. Oh, back up here, get the period in the range first. Adam, the period. Period is 0 to 360 degrees. It goes right around until we get back to 30. My range, what did I say range was? Highest point to lowest point, which is 30 to 10. Alright. So we're just putting a real life application on what we were doing this morning. Period. We can see it goes around 360 until it gets back to 30. And we can see the range is the highest point minus the lowest, which is 30 to 10. Right, off you go, draw a little graph that's up. I'm going to jump to the jacks really quick. Right guys, how we got on our graph? So, just a quick little graph. Five, 10, 15, 20, 25, and 30. Obviously, you'd have to do that
with hopefully a ruler. 60, 90. Right, 30 we had, when 0 degrees it starts at 30. When it's at 90 degrees, 18.28. 90 degrees, 18.28, about there. When it's at 180, it's at 10. Geez, I did some jump there. My God. It was impressive. 120, 150, 180. So 180 then is 10. 270 is 18.28. And 360 is back up to 30. So we can see then. And hopefully you do a better job on your copy than that. Pick up more marks than I did. Right, let's look at the next bit of 3D problem. So, first little bit was a horrible little thing. They asked us, referring to diagram 1, 2, and 3 near the start of this question, for which of the 3 positions of the mechanism with a 1 degree change in alpha caused the greatest change in the position of C. Some people wasted nearly 15 minutes there. What they did is, referring to diagram 1, 2, and 3. They went back up here and did a load of possibilities. So they went up here and it goes, right, if I change 1 degree this way, 1 degree this way, the load of the lessons. What you have to know is just a bit of common knowledge on this one, and there's no other way about it. It asks us, referring to diagrams 1, 2, and 3, here to start the question, which of the 3 positions in the mechanism with a 1 degree change in alpha caused the greatest change in the position of C? So what they want us to do here is check if you move 1 degree that way, 1 degree that way, would this move more, or 1 degree that way, 1 degree that way, would this move more, or move this 1 degree that way, 1 degree that way, would this move more. The closer it is to 90 degrees, the more of a change that happens. That's just a bit of note. But basically, you have to have knowledge of that. Alright, just something you want to take down. Something you want to take down. The greater, the closer it is to 90 degrees, the more effect it will have on the graph in a 1 degree change. So that's just a note. The closer it is to 90 degrees, the more change it will have on the graph. It was a horrible question to ask. People wasted an amount of time out. Right. Back to some more 3D problems. Diagram below shows another crank and slider mechanism with different dimensions in the diagram. AB is equal to 36 centimeters, AX is equal to 31 centimeters, and BAO is equal to 10 degrees. Note OBA is not 90 degrees. Find R, the length of the crank, and give your answer in CM. So, this crank is now different, i.e. this is now a different slider mechanism. So, this is no longer 30 and this is no longer 10. It's a different slider mechanism. They want us to find R. Could I change?
Join BTX to create that triangle and then use cosine straight away.
And you get, what would you get there? You get?
This is BX1.
Yeah, you get BX. That's one way of doing it. From that, you can join a line to BX, and you could use cosine rule. So, if I go do that, off you go.
cosine rule, so your log. So draw a line here for beta x. All of these I know obviously on the example before it, and you draw a quick little sketch for this so you can see what you're happy with. Wait, 25 minutes left, please. Less 20. We get another example question after this. Anyone who's a bit confused about what we're doing, give me a shout out around that. As Adam said, we're doing beta x, we're going to use cosine root of beta x. There's 4 different ways of doing this question. Memory serves me correct. This is one. Right, let's look at the cosine rule for that then. So, we're looking for side A. So, you have angle A, side B, and side C. So, A squared equals 36 to be squared plus 31 to be squared minus 2 times 36 times 31 times the cos of 10 degrees. So, A squared equals 36 squared is 1296 plus 31 squared is 961 minus 2 times 36 times 31 times the cos of 10, which is minus 2198.0909. So A is equal to the square root of all that, which is 1296 plus 961 minus 2198.0909, which is the square root of 58.9091. We're all happy with 7.675? So we know A is 7.65222. Right. What that was. Right. What are we going to do with that? Try and wrangle X now. You can find angle BXO. Man. How will that help us? You can angle on the side of the triangle with this. What do we know about BXO and OBX? Where are they the same angle? Why is OBX and OXB the same? I don't know why OBX and OXB are the same. When have you ever seen angles the same in a triangle? Not equilateral. Isosceles triangle. Why is that an isosceles triangle? They're both radiuses. Both here is a radius, and both here is a radius because they're both lengths. So, off we go and get the angle x. How are we going to get the angle x? Sine it. We're going to use this degree, and this side, we're going to use this side, we're looking for this degree. And then we'll get both of those angles. So off we go. 55 here.
Yeah.
Sure, that's right. No, I get 55 with it. Let's look at it. Right, so B A X. This is 36, 10 degrees. A is 7.65, and this is 31. So we say 36 over the sine of x is equal to 7.65 over the sine of 10 degrees, isn't it? So then that is multiply across by sine 10 sine x, sine x sine 10, sine x sine 10. Back up here then, that is sine x and sine x cancel, sine 10 and sine 10 cancel, sine 10 degrees by 36 is equal to 7.65 times the sine of x. Divide both sides by 7.65. So sine of 10 times 36 divided by 7.65. Do you get 0.81716? 716 is equal to the sine of x. Shift store A. Shift sine inverse of alpha A. 54.80. 8022 equals x, which is 55 degrees. Right. What's the problem now? I remember this from TRIG when you use the sine cosine rule. Look at that triangle. Does it look like 55 degrees? What we've done is right. What we got to do? Sine and cosine rule for operating triangles only operates between digits. Less, take it away from 180. It's an absolute angle. Has to be acute. It's an absolute angle. Can't have it. So you take 55 away from 180, and in here is, and this one here is 55 degrees. Is that right? Very, very hard. Always have a look at it when you're looking at it. Can't get juice. Yeah, 125 minus 55 degrees, which is, sorry, 180 minus 55 degrees, which is 125. So that means there is 125 degrees, and there's 55 degrees, and that up there is 55 degrees as well. And what's this over here? 55 and 55 is 100 and? Yeah, 70 degrees. So how are we going to find R then? Sine rule again. 7.65 over 70 is equal to R over 55. What are we getting? Jesus, Fahrenheit, whatever the hell that is. 7.65 over the sine of 70 is equal to R over sine 55. Multiply across by sine 55 and we're getting 6.66 is equal to R, so 7 centimeters equals R. And that was, I think it was a 15 or 20 marker. I think it was 15 marker question that year. Right, as I said, numerous different ways of doing that question. One way is you could have went straight off the bat with the sine rule of 31 plus R across from R over sine of 10 is equal to 31 plus 9. You put 31 plus R across 36. The same way I say it in my head at the moment. There is another way of doing it with 31 plus R, but the way I went about it, that's the way I went about that here. Is that alright? Right, let's look at another rule just before we go. Another type of 3D diagram. Right, off we go, first two bits, and go we're finish off. 6-7 minutes then. Start a bit late. The reason we're doing this one and not the one in 2017, it was a horrific question. We'll go with the first two bits and we'll struggle to be shit. a third bit there. Look.
Finish this up then next week. We'll finish off 3D problems and we'll look at a few more trigs before last week. We start integration of the last week. The homework this week will be drawing graphs and 3D problems. Give you 1 more minute before I rat through that, and you're free for the weekend. So 3 or 4 different ways of doing this. These 3D problems is loaded.
Right, we give them a go. See how we get on. So, with the first one, the easiest way to go about it was use the triangle on the bottom. That one there. Which was F, C, and D. And you have a right angle triangle there. Come across. 3, 2.5, and we get x, and then what we do once we get x, we half it. So, x to be squared is equal to 3.5 to be squared plus 2.5 to be squared. X is equal to the square root of 3.5 to be squared plus 2.5 to be squared. That's the square root of 3.5 to be squared plus 2.5 to be squared, which is x is equal to 4.3 divided by 2, again 2.15. Oh yeah, I was wondering what was going on there. Thank you very much. It's 3, not 3.5. Square root of 3 to be squared plus 2.5 to be squared is, yeah, 3.915. Right, there's the first one. So, Then, how are we going to get the angle elevation from B to C? The angle elevation B to C is 50 degrees, so that one in there is 50 degrees. Show that AB, from A up to B, is 2.3. So, once again, you draw your little triangle again. There's my A, there's my C. So my B is on top actually, isn't it? B is on top. There's my A in the bottom. Right, if that's a right angle, and we're told this over here is 50 degrees. Do we know any of these measurements? We know A to C is 1.95. How are we going to get from A to B? If this is the angle, this is my opposite, this is my hypotenuse, and this is my adjacent. Which one are we going to use? Tan, exactly. Tan of 50 degrees is equal to the opposite, which is x, over the adjacent, which is 1.95. Multiply across by 1.95 to get it onto the bottom line. Knock that out, knock that out. 1.95 multiplied by the tan of 50 is 2.23, which is exactly what they want. 2.3 is equal to AB. And the last one, find the distance from B to C. We just use Pythagoras, exactly. So it's BC squared equals 1.95 to be squared plus 2.3 to be squared. BC squared equals 9.0925. BC is equal to the square root of 9.0925. What's that yoke? I don't know what the hell it was. 9.0925. 3.015. Correct to the nearest meter, 3 meters. Right, what you did there is probably going to be fairly stereotypical of what goes on, and probably one of these type of questions will be going on this evening as well, but it won't be as hard. This was a horrible question. They didn't give you any figures, they kept getting you to use like ETs and BCs and square them, and it was just a horrible question. So we'll run at that maybe at the end of next week, but we might leave it till the paper 2 revision next year as well. I kind of probably leave the harder questions till the last block, the last 6 weeks block, 7 weeks block is going to be 4 weeks of just doing paper 1s, and the last 3 weeks then will be paper 2s. And then generally what I do is it's on me the week between the Sunday between your paper 1 and your paper 2, because your paper 1's on a Friday evening, your paper 2's on a Monday morning, and that Saturday I generally go back in and run over paper 2 then again. Is that alright? Right, I'll see you next week, guys, alright? It'll be last week of TRIG, and then the final week, don't forget that's on the Thursday now, not the Saturday. 7 to half 8 on the Thursday. That's Thursday the 13th. 12th. Thank you, Eva.